Hello everyone, you're welcome to this channel once again. Today we shall be discussing a question from aerodynamic point of reference. Once again, we shall be discussing a question from aerodynamic point of reference. Now let's read through the question we're given today. Colonization of moon will require an improved understanding of fluid flow under reduced gravitational force. The gravitational force on the moon is 1:5 ratio, that is 1/5 ratio, that on the surface on Earth. An engineer is designing a model experiment for the flow in a conduit on the moon. The important scaling parameters are the Froude number and the Reynolds number. The model will be full scale. The kinematic viscosity of the fluid to be used on the moon is 0.5 times 10 to the power -5 meters squared per second. Now, calculate the kinematic viscosity of the fluid to be used for the model on Earth. Once again, calculate the kinematic viscosity of the fluid to be used for the model on Earth. Now, we were given in this particular question that the gravity ratio for an object from the moon to Earth is ratio 1:5, which is given. Now, by using the formula for the Reynolds and the Froude numbers, we have the Reynolds number equation to be V L over the kinematic viscosity, and the Froude number equation to be V over the square root of GL. Now, by applying the law of similarity, or by agreeing with similarity for the prototype and the model, by using or by juxtaposing the equation, we can juxtapose the equation given here, that is the Froude number equation, to be V R equals GR raised to, or in the bracket, raised to power 1/2. From there, as we know that the ratio for the VR will becomes the ratio for the kinematic viscosity of the moon to the Earth, which is written here. So therefore, we have G moon over G Earth, which gives us 1/5, all raised to power 1/2. So therefore, our kinematic ratio for the Earth and the moon equals 1/5 raised to power -12. So therefore, the kinematic viscosity for the model on Earth becomes this, which is equals Vm multiplied by 1/5 raised to power -2. So our calculated kinematic viscosity for the fluid model on Earth becomes 1.12 times 10 to the power -5 meters squared per second. Once again, the calculated kinematic viscosity for the fluid model on Earth becomes 1.12 times 10 to the power -5 meters squared over seconds. Thank you.